Here's something pretty cool about macrolide antibiotics that you probably didn't know. For those who've never been to my page, my name is Justin. I was a former paramedic turned a pharmacist, and now I just love to educate. So when I say macrolide, I actually mean a class of antibiotics that you would know familiar as like azithromycin, clarithromycin, or even erythromycin. The term macrolide actually stems from where its structure. So macro is large. As you can see, it's a very large 14 minimum carbon ring. And the lide actually comes from the lactone, which is right here, the double bond O. It stems from that, as well as these two sugar moieties that are attached to it. So macrolides have a pretty unique mechanism of action. What they do is they bind to the ribosomes, the 50S specifically subunit at the P site, and they also block another enzyme from working, which is the peptidyltransferase enzyme. That enzyme is actually responsible for creating these bonds between two amino acids between the A site and the P site. But recently, there's been more data to show that certain bacteria strains, like Staph aureus, for example, have grown resistant to macrolide antibiotics. Just to kind of give you an example, if you look at here, the yellow ball is the actual drug, macrolide, and then you have the antibiotic binding site, which is that blue ring. Notice how there is an ester, which is circled right here, and bacteria develop an esterase, which breaks down that ester and hydrolyzes it. This in turn makes the antibiotic completely useless, making it more resistant. So the next time you see any kind of azithromycin or clarithromycin or anything like that, now you have a better understanding.